My name is Schumacher, and thanks for coming to this session. We're going to be talking about what I entitled The Thinking Person's Guide to Data Warehouse Design. I entitled this because I feel that there is not a lot of thought that goes into creating data warehouses these days. And I'm hoping to maybe give you some ideas to avoid some of the mistakes that I've made in the past. Give you a little bit of background about myself. Yes, today I'm VP of Products at Calpont. We make a column-oriented data warehouse engine for MySQL. It's MVP-based and such. I'll talk a little bit about that, but not a whole lot during this session. Prior to that, I was 4 years as the Director of Product Management with MySQL. And so ran the MySQL product line for that length of time. Prior to that, I made database tools. Database tools company for Oracle, SQL Server, Sybase, DB2, and MySQL. And prior to that, I was a DBA in the field with all of those databases, including Teradata. And have done data warehousing with Teradata, with Oracle, with SQL Server. And today, of course, we do some data warehousing with MySQL, with our engine. The agenda is pretty simple in terms of what we're going to be walking through. I'm going to be talking about building a logical design and how you begin with that. And I have to be really upfront and honest with you because there are data modelers who just get really into that. And I was always more of a physical modeling kind of guy. I did the logical stuff, and I'll show you some things you need to keep in mind. But really, it's still with a mindset that, hey, look, this is going to become a database that, by the way, is going to have to run fast at some point. So we're going to have to break some rules to make that happen. And that's how I always approach data modeling. So that's how I'm going to be kind of discussing that. We're going to talk about then how to transition to a physical design. And that's taking that logical design that you've created in a modeling tool or something and now slapping it down on a physical MySQL server that you're going to make some modifications to. And that design is going to be very, very important. And I'll show you why and how that's the case. And then finally, we're going to talk about how to monitor and tune the design. I have built some really nice database monitors that look real sexy in terms of the interfaces and the graphs and all the stuff that it does. And the thing you really need to keep in mind, whether it's Nagios or whether you use the Enterprise Monitor with MySQL or some third-party tool, whatever monitoring tool that you use, you are really monitoring your database design. That's what you're monitoring. Now, there's going to be some SQL analysis you're going to have to do, and I'll talk about that as well. But in general, really, when all your monitoring tool is doing, when it's screaming at you with the bells and whistles and the notifications and the graphs, it's all saying you've flunked your design test. And we'll talk about how to approach design, monitoring that design, and what to do about it as we roll along. So let's first talk about building a logical design. Perfectly okay question to ask, because a lot of people don't even approach design. They just slap tables together, pump data into it, and flip the switch and hope it runs. Why should you even care about design? Well, Oracle's own numbers, they did a study a while back, and showed that it is the #1 contributor to downtime, it is the #1 contributor to performance problems. When you have a bad design, it wrecks everything. It is a wrecking ball that will come through your system. And your phone will start ringing and systems will crash if you don't do this properly. And that's why you should care. And that's why you should take some upfront effort to devote to your design. Because if you don't, you will get paid, you will pay the piper sooner or later. It will happen. And so that's really why you care. #1, again, in terms of outage and performance problems, comes from a bad design. So let's look a little bit at this. Not surprisingly, this study, Phil Russum by TDWI, if you guys, I don't know if you're familiar with that, it's the Data Warehousing Institute. You know, these guys actually, this survey, by the way, and I've put this down here, I would write that down and go get it, because it is not marketing fluff. It's actually very good information for you if you are constructing a data warehouse, you're building a business intelligence system. This is a decent report for you to get, and I'll show you some graphs from it as we roll along. But he's polled some very sophisticated people that are building some heavy-duty data warehouses, and it's got some really nice information for you. And so I would go out and get it if I were you. One question they ask, and this is not surprising, well, what's the #1 contributor to your BI system, right? Well, it's going to be the database server, 3/4%. So if you're responsible, and I assume since you're sitting here that you are, for building a data warehouse, being responsible for it in some form or fashion, designing it, administering it, whatever, you're in the hot seat, right? You are up front, spotlight is on you. And if you don't do this right, again, nothing else is really going to work too well. And again, they spell that out in this survey.
Will you have your slides available?
I do. I'll put them out there. I'll put something out on Planet MySQL and make sure that you guys can get them, absolutely. First pitch I do want to make, just me personally, if you don't use a modeling tool today, now again, I've already kind of slapped logical modeling a little bit in terms of just, I've always been a physical-minded modeler and a DBA, but still, use a modeling tool. If you don't today, don't do it an old-fashioned way. Get a modeling tool. Workbench from MySQL is free. It works pretty darn well. It's got some very nice features in it. When I was designing warehouses and just OLTP systems, I lived in my modeling tools. Because you can capture everything there. You can capture all of your entities, relationships, attributes, or in other words, tables, referential integrity, and columns. You can do all that really well. You can use it as a change control system. So you can capture a design in your index design, you can implement it, and if it doesn't work well, you can change it and keep iterations of that and go back and forth and see which design worked best. So you can do some very nice change control. It does great DDL generation. If you're creating a monster system, a semicolon out of place, a tick out of place, your script's not going to run. It's not going to happen with these tools because they generally do it right the first time, which is nice. So you can use it for that function. They have some nice reporting functions. So if you've got to give a design to a set of developers who are going to be creating the interfaces and or business intelligence analysts who have to query it, these things with one click will create you a nice Word or Open Office document. You can hand to people PDF docs you can put on a website. So they do a lot for you. And it'll take a lot of burden off your back if you start using one of these modeling tools. And again, Workbench is one. Quest makes some nice tools, modeling tools that you can use. There's other folks that do it as well. So I would really encourage you to get a modeling tool. Now, all right, so that said, here's what your typical OLTP design looks like. And if you've done a transactional system, you probably know about the third normal form and different forms that you're working with. So your entities, you've got a primary key, and any of the attributes underneath should only reference that primary key. They should not reference other columns. And then, of course, you've got foreign key relationships between the different entities in the model. And then you've got self-referencing entities like this that will reference each other. So you do this, and it works really well for an OLTP system. It does. That's why the relational design is still champ today. No question about it. But here's what happens. So you do this, and then you take your transactional system, and then you just put it over and you create a reporting database out of it, and that's going to be your data warehouse. That's going to be your BI system. Now, sometimes that works. A lot of times it doesn't work very well. But I did this one time. I was in charge of an Oracle financial system, which is a beast to manage, by the way. And all I did was on an EMC box, and so we just did a mirror snap of the Oracle database and just pumped it over into a different location, and we aimed all of the business intelligence queries, all of the decision support stuff at that, and let the general Oracle financial systems run along, and it did okay, it was fine for a while. But now here's what happens. Again, sometimes it works and sometimes it doesn't. So I was asked to look at a reporting system that was done that way. Their reports were taking hours to run. It was excruciatingly painful. It's one of those things where they have to throw it into the night time, right? So it'd be ready in the morning because it was running so slow. They said, well, you come look at this. And sure. And so you, as a DBA, you try to look at the things that are quick fix first. Have you set are your config params right? Any contention on the box? And there's a Unix system and all that type of thing. And I didn't really find anything out of whack there, which was a bummer. So I said, okay, let's start looking at some of your queries that you're running. What drives your reports? So they gave me one of the queries that ran the reports, and on the surface it didn't look very evil. It was about a 6-way table join, a lot of columns selected, etc. But I looked at it, I thought, well, it's not so bad. But then I asked the question, all right, are these objects here, are these tables or views that you're referencing? Oh, they're views. Ah. So I pulled the DDL from one of the views, the very first one. It was a 33-way table join. 29 of the join predicates were outer joins. Okay, problem. That was the first one in that array. That's what happens when you just try to take that OLTP system that's highly normalized, and now you're going to have a data warehouse and a reporting system. It just doesn't function. So I got with a DBA who was a real bear to deal with, wouldn't change anything. And so what I ended up doing was taking a little ETL tool at the time. It was ETL before ETL was cool. And we basically created a set of denormalized reporting tables out of that OLTP extract and built that. And those queries, or those reports, then went from taking hours to run. If you needed to do the whole ETL run and the report, it took 12 minutes. And if you just needed to run the report, it took about 3 minutes. Just because, again, the data was massaged, the model was massaged, the design was massaged. And that's the kind of thing you can do when you get your design right. So for data warehouses, if you've done them, you know about the star schema. This is pretty popular, and what you've got is a bunch of what are called dimension tables that are smaller type lookup tables that contain elements that then reference this monster in the middle, the fact table, which is where the real data is, and that's going to get attacked most often by the BI queries. And this design works pretty darn well. There are others called snowflakes and such. I really didn't include those because I don't really care much for those. I understand how they work, but I prefer just a more simpler design like this, which is a star schema. And again, it typically does work quite well in data warehouse systems, just in terms of having, again, the dimensions referencing the actual fact. Now, the things that you're going to be deciding at this point, at this stage when you're laying this foundation, you're going to be looking at data types, but you really don't care too much about them in terms of the specifics. So you know I need a number versus a text versus a variable character, something like that, but you're not going down to the level of the database engine at this point, because maybe you haven't selected it. Maybe it's going to be Oracle, maybe it's going to be Sybase, maybe it's going to be MySQL, who knows. We don't really know at that point. Now you heard Brian this morning talk in his, that a lot of times data types don't make a difference, and the processor ignores them. Sometimes they do though. Sometimes they do. So when you are using smaller data types, they can take up less storage at times, they can be faster to reference, sometimes not. And so you do need to keep that in mind. You're really not designing for performance initially at this point, but I typically always did, and still kept that in the back of my mind. So you're trying to avoid data redundancy, having different elements everywhere, but at the same time you want to keep simplicity so you don't have 33-way table joins going on. That's very important. So you want to make sure it's correctly represented, easily understood, which is important because today we have a new class of user that's going up against these relational models. These tend to be business users that maybe have an Excel spreadsheet and an ODBC driver that they can hook into these things and begin to pull data down. And so if you've got a monster type of schema that they're trying to work with, oftentimes it's not that they're not going to try. Oh, they'll try, but they're going to cause you some pain because your phone's going to start ringing, or they'll be creating queries from somewhere 80s. You heard Brian this morning talk about the Cartesian join. Microsoft Excel does that, by the way. If you've ever used Excel up against MySQL or any of the others, one of the things it does with its query editor, it will fire off Cartesian joins underneath the covers. So do be aware that that does occur. Now, some things that also you need to keep in mind at this stage is some partitioning at the modeling level. Now, I'm not talking partitioning yet at the physical layer. This is the modeling layer. So what oftentimes modelers will do, they will build into their model a horizontal partitioning scheme right up front. So you might have things like an approval table or an approval entity, and you begin to split those out by years already in your logical design. So you'll have them from 2006, 2004, whatever. You begin to create these now in your model before it ever hits the database server because you already know what's going to maybe happen or something. Now sometimes this will happen because maybe these will contain different elements, but oftentimes that's when you do vertical partitioning. These are most often just mirror copies of the actual entity itself. And what usually happens in a physical design is this guy goes away. There is no approval entity or table. There's just these that are left. And that's what typically happens there. Now the second is, and this was really done before the advent of the column-oriented databases, and I'll talk about that in a moment and how you can benefit from those in a second, as MySQL users. But what modelers would do here is they would do a vertical split. And the reasoning is, okay, if I have a real wide table, since most databases are row-based operations, insert, delete, and select, and all that type of thing, and down, let's split it out so that I'm not having so much I/O that's going to be done. And they'll begin to do that. So you might have an approvals table, and then there'll be an applicants table where you'll have certain columns that only references the approvals if it's an applicant, versus if it's a product approvals. So you'll have certain columns that might reference it. Right? So you'll be doing some of this vertical partitioning already, again, in the hopes of maybe as a modeler you're doing it because maybe some of these data elements down here don't reference the primary key in the original parent, but in the children, that's when you break it out so that you actually normalize it properly. That's when people will start doing that type of thing. But again, most often, people like myself would do it, again, for performance reasons. And that's when you'll begin to do that. Now, there's some pros and cons you need to be aware of if you're going to do this. First off, you will, if your design holds up, have less I/O to deal with at the database layer. And what I mean there is, if you've done it right, if you're going after those children in a vertical partition scheme, you're going to be doing less I/O when it goes and it does a row-level grab for that data. That'll work if the design holds up. All right, and I'll talk more about that in the cons here. It's easier to prune obsolete data. So if, for example, rather than have this one large table that's sitting out there for approvals, if I have approvals 2006, 2005, if I break those up, I can just do a drop table. And boom, it's gone. DDL operation done. As opposed to a massive delete that takes a long time, locks tables, fragments tables. So that is nice. And oftentimes you'll have less object contention because if I have multiple objects, I'll have less locking issues that I have to deal with as a DBA. I can load tables while others are being queried with maybe less contention. That type of thing is going on as well. Now there are some cons to deal with here. Obviously when it hits the actual physical database server, you're going to have more tables to manage, more RI to take care of, more indexes to take care of because you're going to be duplicating indexes, primary key indexes, maybe foreign key indexes, all that type of thing. But here's the real booger that will get you. If, indeed, the query patterns that you think are going to happen don't happen, and you end up having to join these guys anyway, it almost gets worse. In fact, oftentimes it does get worse. So I don't think I'm going to need to reference 2007 and 2008 data together. Oh, wow, I do. So now I create a view and I think, well, I've solved the problem from an entity perspective, yes, or an object perspective, but the performance is still going to suffer. So you're going to have that as an issue. And same thing here, really. That's when you then begin to think, okay, now I have to physically redesign things because, again, what you thought would happen from a query access pattern has not happened, and now you've got to change things. All right? So the bottom line here, just from this first little segment we're talking about, just to summarize, get a modeling tool, because it will help you. You don't want to use an OLTP schema, please. Make it simple and understandable because your class of user today who's going to be going up against this is going to thank you, and it will make your life easier too because they're not going to bug you as much if they understand it. Manual partitioning is fine. I'm not saying don't do it, but today, because of what the database engines will do for you, MySQL and others, oftentimes it can be better not to do that. There's certain storage engines like Spider and others that will help you now that are out. We do some of this as well. Again, not saying don't do it. If you do a good job at predicting and you feel certain that the breaks you're making at that layer are going to hold out, great. But if not, it becomes almost easier sometimes to let the database engine do that for you, and I'll show you that in a second. All right, so now let's talk about transitioning. So you got your model, things look good. Let's lay it down on a physical box, and here are some questions you're going to need to answer. So, what about HA? What do I index? How do I partition? Do I look at row or column databases? How do I scale this thing? Is it going to get scary for me at some point, where you're actually scared of the data, whether it's going to be future-proof or not, what you're designing here. So these are some of the things that you have to keep in mind, and we'll try to walk through each one of these questions and see what answers we can have. So we're going to talk about just general architecture, data orientation, some storage engine selection, partitioning, indexing, and how to optimize for your data loads, which also become very, very important too. If you have a dynamic data warehouse where data is coming in all the time, right, that's going to become very important for you, that last point. Okay? They say that in a typical talk like this, that you only take away 10% of what I say. Now that's depressing, really. Because we work hard on these presentations, and we want you to remember everything.
Choose your words carefully.
Yeah. So that's what I'm about to do. He said, choose your words carefully. If you're only going to take away 10% of what I tell you, then pay attention, please, now. Because this is the stuff you do want to remember. The divide and conquer strategy, when you're approaching your physical design, is the best way to do it. It is. And the thing is, it's the same strategy Teradata has been using for years. That, you know, when you look at those little Gartner studies where they are tracking all the data warehouse databases and everybody else, that's why Teradata is all the way up into the high to the right, because they do this better than anybody. They divide and conquer. What does Teradata do? Right? They take all your lovely data as it's coming in. They hash it. They pump it through this intelligent YNAT that distributes the data across as many nodes as you have your gold card for. And believe me, you do need to bring your gold card when you're talking to Teradata. Right? First one I did was about $1 million, $1.5 million, and that was back in the early 90s. Okay, I don't even know what the price tags are today. But what they do is they take your data and they hash it across what are called AMPs, Access Module Processors, which are nothing more than processing systems. Okay? And that's connected to local storage, shared nothing architecture, with redundancy automatically built in. And they call it just not failover, fallback is what they call it. So when you create it, you can just click a button and say fallback, and it creates redundancy of your data across those different shared nothing nodes. And then when your query comes in, it then parallelizes that query using that hashing algorithm again, and all those nodes go to work for you and go after its own subsets of data, and then it pushes it back up to the end user. It's kind of like a MapReduce type of thing, huh? What people are doing with Hadoop, what people are doing with Cassandra, some of the other things, it's all divide and conquer. Now, I'm not saying again, if you have small data marts that put them on a single box, they may live there happily forever. But if it's going to grow, if it's going to get bigger on you, and things like that, that's where divide and conquer is your best friend. All right? Because you're going to hit disk and memory and other limitations and all of that type of thing. So the best thing you want is something where you can scale up and scale out, and that's not easy with MySQL. All right? Really, MySQL cluster today and InnoDB plugin can address more than 4 cores or CPUs on a box. The others cannot. All right? Throw biggest box you can at it, but they cannot. And that was very depressing for the Sun people after they bought us to find some of this out. You can imagine why. But it's the case. And so that's where your storage engine selection is going to become important to you. That's when you need to ask questions. When I kick off a query, how many processors is it going to use? Okay, and if the answer is 1 or it hits a wall, that's when you might want to start considering something else. Again, your own tests will bear this out, your data loads will bear this out, your data volumes rather, and maybe it'll live fine, but divide and conquer is what you want to try to do, right? So that was my 10%. Now, the stuff you'll forget, let's just keep going. Sharding, very popular. So the MySQL professional service guys, they do this and they do it well. Lots of good testimonies, case studies out there for you to look at. Basically what you're doing is you're creating domains of certain data. So for example, you're a travel site. Hotel goes here, car rentals go here, airline, there, and you work your way down. Now the drag is when I visited some of our customers, it can get out of hand. So I visited one, they had like 40 shards, they had to hire a guy doing full-time sharding work, and they just didn't like it because it became kind of an administrative form. But if it's contained pretty well, then it's a decent solution that you can look at. Now, what technologies should you be looking at for your design? Right? Here again is a piece of Russell's article that again, or a study that I would recommend to you. And these are what people are looking at and buying today. All right? So let's start, I've got this lovely thing here. Let's start with what you don't want to be buying and what you don't want to be looking at, according to some of the experts out here that are doing this stuff full time. At the end here, you see that SMP is not really what people are looking for. All right, SMPs, multiprocessing. Again, this is scale up. It's fine if I want my queries in my database to address all my processors, but that's really not what I'm looking at for my future. That's what that's saying. And databases built for transactions, that's not what I'm looking at either. OLTP processing, way different than query, read-intensive data warehouse processing. And people today get that. And you ought to get that as well. Because there are a new crop of solutions out there that will make your life easier, and you will be oftentimes stunned at how much better and faster they'll run your stuff for you. All right? So that's what people are not doing. Now what people are doing You heard Brian this morning also talk, 64-bit, absolutely. Other things people are looking at, MPP, massive parallel processing, that's divide and conquer. Right? That's what people are trying to do. There's other stuff in the study that shows you that literally almost 3/4 of them are now beginning to plan for MPP or divide and conquer strategies for their large data. That's just how people are doing things. As you then begin to get down here, you look at column databases, in-memory databases, the open source databases. Don't be worried, by the way, that it's way down here, because all that means is they just haven't cut a check for it yet. Right? They want to do it, it's gaining popularity, they just haven't written a check for it yet, is what that is trying to say. All right? So these are the types of technologies that, again, you should be looking at when you're creating this physical design. Okay? Am I laying that foundation right? Because if you don't lay that foundation right, oftentimes it gets kind of tough to make that switch. Sometimes yes, sometimes no, but try to make the right call the first time. All right? Now, the next question you need to ask, do I want a row-based database or a column-based engine? Now, the great thing for you is today with MySQL, you have choices, nice choices, and choices that aren't going to cost you a lot of money, and choices that are going to perform pretty well for you. Now, you would expect, since I work at Calpont, that I'm going to tell you, man, you need a column database and that's all you're ever going to need. But that's not true. Okay, that's untruthful, and I'm not going to say that. There are use cases when it's going to help you out very well. I've also sat in front of government boards where they're telling me, you know what, we've done tests and we've got a row-based database that's outperforming a column database. So you're going to need to make that call. Now here's some of the things to consider to make that call right the first time. Row-based databases are going to do you really well when you need most of the columns in your table. So you've laid out a wide table or whatever table, and your queries most of the time will be accessing all of those columns in a query. Select first name, last name, address, blah, 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 and it's getting all the columns. Row-based database is going to be much better for you, all right? Because a column database is going to have to touch all those columns and get those out. It's different I/O for them rather than a one I/O sweep to grab that row. So that's going to be better. If you're going to be doing a lot of single inserts and deletes, so that's how your data is going to be manipulated. It's coming in with singleton inserts, and when you remove rows is delete operations. Column databases typically stink at this. Now Vertica tries, I don't know if you've heard of Vertica, Stonebreaker's company, they try to get around this by having this tuple mover where it comes in as a row, and then they do this under the covers transformation as a column. I haven't heard a lot of good stories about that working well. Nice idea if it works well. I've just not heard great news that it does that. So typically, a column-based database, it works fine. For example, our engine, others, you can insert and delete all day long. That's fine. We're transactional, crash recovery, you get all that. But just understand a column database is not going to run those DML statements as fast. And if it's a requirement that they get in very, very quickly, well, then a row-based database will do that better. Now updates, it's a different animal, because that's a column-based operation, right? So you'll be fine with that DML statement. But inserts and deletes, keep that in mind. Small, medium data, not a lot of data, that's where a row-based table, you're not going to see the benefit, the bang for the buck with a column-based that you will, if it's very, very large amounts of data, that's when those things will tend to shine, all right? Small, small differential, not that meaningful. And you know exactly what to index. That's also very important. Because if you have an ad hoc query environment where you can't predict what people are going to select, you can't predict what's in that where clause, all right? Tough to index. And you guys, if you've been around MySQL long enough, it ain't easy to change those indexes. There's locking issues and all that type of stuff you got to deal with. Can get to be kind of a bear. I visited one place in Chicago, huge retailer, and this was killing them, just killing them. Changing that, some of the the index drop ads taking like all night to run because of their volume of data. Okay, so, but if you know what to index and it's going to be static, then that's good, that's fine, and a row-based is going to be your boy. On the column side, subset of columns. So you're not going to be selecting all the columns. Fast data loads, but little DML. You're populating your data warehouse or marts via flat files or feeds in from another system, and you're using a high-speed loader that's designed to kick that stuff in fast. Large data, this is where it excels. Okay? So if you're going after a large amount of data, analyzing a lot of data to do your analytics and stuff like that, these guys are going to be great at it. And that's just a matter of fact. And very dynamic. So you, again, can't predict the query patterns. You've got people shooting in from Excel and BI tools and reporting dashboards and all this stuff where they can do their own thing. Great thing about column databases, no indexing. There is no indexing. Yes, sir?
I need both.
I'll get you in just about 3 slides.
Good.
I'll get you in 3 slides.
I mean, on the same database, by the way.
I hear you.
Okay.
You're in luck.
Good. I'm not a plant. I don't know if I'm leading up to something.
We'll see if it's, yes, and we'll see if you're in luck, actually. I don't know if you'll think that, but we'll see. All right. So,
you mean no indexing because just the primary key index.
Column is the, well, there's 2 reasons.
Well,
First,
key isn't.
yeah, the column is the index.
Oh.
And secondly, most of them will use a technique to get around indexing. So we use something called an extent map, where we know exactly where the data is. It's all metadata populated. It obviates the need for indexes. You don't have to deal with it. InfoBright uses a knowledge grid. Very, very powerful metadata repository. Netezza uses what are called zone maps. Oracle Exadata uses storage indexes, which are exactly like our extent map that we use. So they also, not only do you have the column as the index, but they will also have other structures that they'll use that you don't have to deal with, which is great. It automatically does it for you to get you around the indexing. Yes?
What is the threshold for medium-sized data?
The question was, what is the threshold for medium-sized data? It's been my experience with the customers that I have dealt with at MySQL, and I'm sure we will have, you know, there are exceptions, but I have seen about 500 gig being about the limit that people say, look, when I begin to deploy some of these specialized engines, that's when I see benefits. Sometimes it's a lot smaller data because oftentimes the query complexity itself dictates the performance. So, but as a rule of thumb, that's what I have seen occur. Okay, now, some of you may be saying, I don't even know what a column database is. Real quick, I'm not going to spend a lot of time on this. Here's your table over here, right? Logical table. So, row-oriented database basically stores the rows as you would expect. Column animal does it differently. So it's going to store all the employee numbers together in a file or files on the disk. The department IDs, same thing. Hire dates, same thing. But to you as a MySQL user, you don't see that. All right? You're at a MySQL command prompt. You create your tables. It all looks and tastes the same on the surface. So you're not going to be dealing with it. But underneath the covers, that's what's going on. Right? It's storing the data differently. It's going to be accessing that data differently. And again, think about what we just looked at. Vertical partitioning. That's what it's doing for you. It's doing it for you. So as a modeler, I don't have to do that, which is good. Now, the question becomes, does it really make a difference? I am not showing this to show off Calpont InfinityB. Is there an InfoBright person in the room? No? I know they have some similar benchmarks. Others will as well. But I got a hold of one of my peers that's very, very good in data warehousing, knows this leading database inside and out. If you go to our website, you can read his white paper that he wrote for us. He didn't believe that the no indexing approach, etc., would beat out this leading database. He was skeptical. He knows databases really well, especially data warehousing. I said, look, would you do a product viability test to see what's going on? So he did. And these are the results that he found with us versus the leading database. Now his machine was a 16 CPU, 16 gig of RAM, CentOS, 2 terabytes of raw data. So a lot of data for MySQL. Not for folks like Teradata, but for MySQL, it's a decent amount of data. 22 less space because of our compression that we use, loaded 22% faster than their highest speed loader that they had. The query times were very telling. Total, when you total up all the amount of query time, 65% faster, and on average, nearly 60% faster. And he was doing compression, no compression, range, no range, different types of partitioning schemes. The interesting thing to me was, this is a very sophisticated optimizer. And the differentials were surprising to me. I wouldn't, and this is not just a cold versus cached, he did all that. The nice thing about ours was it was very predictable. And this brings up another point that I want to bring to your attention. Predictability is something your users are going to want a lot of. So when Amy comes in and presses her dashboard for her refresh, if it takes a minute today and 10 minutes tomorrow and 30 seconds the next day and an hour, that's they're not going to be happy. And they will then take their grief out on you. So you really want predictability with your data warehousing. And again, this is oftentimes things that you will get from columns that you won't from others. We're just one of the examples. So that's just something to keep in mind. In terms of, do they make a difference, column versus row, when the use case is right? Yeah, they do. Now, you had asked, I need both. Larry Ellison, when he was giving the Exadata version 2 talk, one of the things he said was, you know, with Exadata version 2, you can do both transactional systems and data warehouse systems on the same box, in the same database, and no one else can do this. Netezza can't do this. Greenplum can't do this. And he named other data warehousing vendors. And he's right. He's right. Except when it comes to us. And I don't mean us as Calpont. I'm sorry about that. Us as MySQL people. Because you actually can use both if you want to. And here's how that works. So it's perfectly fine to use our engine, others' engines that do columns, in the same instance, in the same database. And so you can indeed mix and match and create now what are called hybrid systems. And for someone who's been around for a long time, we did everything in our power to separate these systems. And now it's coming back around again for these hybrid systems where they want to put everything under one roof. Okay, well that's fine. If it works, good. I understand. You can do this. So you can have InnoDB tables or PBXT tables or whatever else and have your transactional systems, your row-oriented tables in a database, and at the same time, you can create tables with us, or with, I know you can do it with InfoBright, I don't know about Kickfire, but you can have both. And it's pretty cool. We're the only ones that can do this now. Now there is another one that's coming. Ingress is planning a column-oriented engine for their systems called VectorWise. I don't know if you've heard of it. They may be able to do this as well. I know that they want to be able to do this. Don't know that they can yet, but anyway, that's what the talk is. Now, here's where some of you are going to get mad, but what you can't do today, and I'm not sure we ever will be able to, possibly, people smarter than me, so I'm sure they'll figure it out. You can't join these together. All right? So you can't join your InnoDB to an InfiniDB table and run your queries. I have seen some people try, and what happens is the optimizer is confused, and it takes longer than if I had done one or the other and just kept them separated, segmented. Okay? But again, you can create transactional systems or row-based. You can have MyISIM. It doesn't have to be InnoDB. All I'm saying is, unlike what Larry Ellison was saying, you guys do have the option. You have the flexibility to do this now. With us, we just ship with the InnoDB plugin, install InnoDB, and it's ready to go. Or MyISIM. Use what you like, but you can do both under the same instance, same database. Yes, sir?
Any technology company to store the same data in two different engines and have some type of optimizer to figure out which one to use?
Boy, that's a good request. I know we're not working on that yet. Great request, but I don't know of one. I know there are people that are trying to do kind of quasi-column row things and stuff. I have no first-hand experience with them. I don't know if they work or not. Nice idea, though. And by the way, I just want to show you this also. I talked about scaling up and out. All right, you can do what we talked about here. Have your hybrid system and scale out as well as up. So with us, the way you would do this is we have a modular layered system, much like Exadata. We're kind of tailored like Exadata, where you have a concurrency layer, then you have an I/O layer. And what would happen is in the modules, you just create your row-based tables in our concurrency layer, which is fine, and then you can scale out for large amounts of data with our performance layer, and you can get the DB plugin to scale up and do its thing, and we'll scale up on that box as well, and these boxes, but you can also scale out. So this is kind of what I was talking about when you're doing your design, again, a future-proof, where you don't have to be afraid of what's coming down the pike, because the linear performance gains you get will take care of you. So if you just had a one-node system, a query that took 10 seconds, if you add a second node, it's going to take 5 seconds. If you add 2 more nodes, it's going to take 2.5 seconds, and that's legit. Okay, that's not, wow, I hope that happens. It will happen. We've done too many tests to see that it won't. So you can do both, and you can scale up and out with both. Okay, that's what I'm trying to get at. Now, also, the other storage engine, things that you need to keep in mind here is the main engines that I saw used in the field, MyISAM, Archive, Memory, and CSV. MyISAM, the most popular because non-transactional and all that kind of stuff that you already know about. Archive is good if you have to push a lot of data in fast. It is, because of its compression that Brian put into it, it beats the socks off NODB and MyISAM when it comes to insert speed for the generic MySQL engines. Now, keep in mind, there's drawbacks to Archive. Table scans, and there's no real indexing and yada, yada, yada. All right? Memory, CSV, the thing I like about the CSV tables is you can take a flat file of data that is laid out with CSV, comma separated value, and you create your shell table in MySQL, and as quickly as you can do an MV command in Linux to move, to just, change the name, rename your flat file to the table name, that's how fast that data is now available to MySQL. It's literally sub-second load, if you want to think of it that way, which is kind of cool. And there's other things you can do with CSV as well that I'll talk about with data loading that's kind of nice. So it's got drawbacks, table scan only and all that stuff, but as a utility type of storage engine for you, it gives you some nice benefits. Now, let me address NoSQL. I am not an expert with this. I hate talking about technologies that I have not gotten my knuckles bloody with, and I have not used these personally. This is just some research I have been doing, and talks I've had with other folks that know it better than me, and it's changing every minute. So some of the things I put up here are probably not true now, and they were an hour ago. But just FYI, obviously it's not relational in most cases. They don't use SQL to access the data, unless it's an also SQL type of scenario. They tend to take up more space primarily because they don't use compression today. So you will get nice compression with some of the row-oriented, especially with the column, because you can compress, use different algorithms for numeric versus character, and you get really nice compression with column databases. They do lack special optimizers to reduce I/O, or things like what I talked about earlier, extent maps and all of that type of thing. They really are row-oriented. Now, they may present as a column, or top columns, but they really aren't. They're more like column families, where you've got a group of, a subset of columns, if you will, and they all are still accessed together. So remember when we talked about vertical partitioning? It's the same type of thing. It really is at that layer. So you can't access those columns individually like you can a column database. It's more like vertical partitioning. They are going to be faster with individual insert, delete. They typically will be faster with single row requests than a column database or data warehousing database will be, but they will lag in the typical use cases, crunching all that data, analyzing that data, and returning subsets of it back to the user. So you will have to determine whether or not these use cases fit your scenario or not. All right, moving on, partitioning. Hopefully you know what partitioning is inside of MySQL. Done pretty decently for a first cut. It's not an if, but how. The PS guys with MySQL will tell you partition every time if you can. Because again, the idea is, with all of this, only select the data that you need. And that's what partitioning does. I don't need these other 9 partitions of data. I only need the data in this one partition. Well, it's going to take a lot less time to read 100,000 rows than 10 million rows. And that's what partitioning will gain you. This is just a typical example. 90% response time reduction, same MyISAM table, 1 partition, 1 not. That's what can happen, again, if your use cases are right. If you take the partitioning key and you're keying off that, your query can make use of that, partitioning is really going to do some nice things for you. And you can do other things. From your physical design, set up and stripe your data across your different spindles and controllers so that you get the benefit there, and you can do that. Note, no, it only works for some storage engines, what I'm showing you here, and only for certain operating systems. So if you're a Win person, not going to work for you. All right? And you can use partition commands to move partitions around. That's not a problem. What a lot of people like is this right here, the pruning aspect. Remember I talked earlier about being able to prune, just drop tables, etc. You get the same thing in partitions. Okay? So you can do a delete, ugly, fragments, takes a long time, lock, blah. Okay? Or if you're smart and you set up your partitions properly, pruning data becomes very easy. DDL command, boom, runs like that. So if you need to drop off data, you only need to keep a year's worth of data, 2 years worth of data, and you have this consistent drop off where this stuff is rolling off, it becomes very easy and very nice when you set it up like this. Okay? So let's move on a little bit more because we're running out of time. In terms of index creation and placement, this is, again, somewhere that you do it right, obviously, and I don't mean to bore you. I mean, you're going to get much better performance in most cases with certain queries when they use index access versus table scans. Duh, right? But you've got to be careful here. If you, again, can predict what your queries are going to be like, and indexing is not that big a deal, all right? That is fine. But in a very ad hoc environment that I've already said, it becomes more difficult. Then you tend to have to change your physical design, change indexing schemes, and etc. And when we talk about monitoring, it's not oftentimes easy to figure out what index is being used in MySQL, unlike other databases where it's a little bit simpler. Over-indexing, this is where you're going to die if you have a constant data load coming into your system. So one system I was taking care of was an Oracle system, and I got a call, things dragging, running terrible, etc. And we had an application DBA who was kind of working with me that I'd given just rights to do, what he wanted. And what he'd done is the hub table that was being loaded into and he accessed frequently, he put 6 bitmap indexes on the thing. Just tore it up from a performance perspective in terms of data coming in. Query, sure. But if you know bitmap indexes, you know that they typically don't do well with updates anyway. It's even uglier than most btrieve indexes. And so as soon as I put a bullet in all of those indexes, the system just took right off again. And it was fine. We had to come up with some different indexing strategies. But over-indexing will kill you. I saw this way back with DB2 when I was loading data into DB2 data. It doesn't matter the database vendor. It will hurt you. So that's why you have to be very smart about how you do your indexing. And maintenance on these things also can cause headaches because it takes a long time, locks the table, etc. Some storage engines don't support indexes like Archive and CSV. And again, not to harp on it, but one of the things I really like about the column databases as a DBA, I don't have to fool with that anymore. I really don't. It takes care of it for me, and I like that. And it actually works. I like that even more. Now talk about loading data and how your design affects the data loads that are coming in. The 2 big killers, again, wide tables and too many indexes, which I've already mentioned. Stating the obvious as it says up there. Inserts and all that type of thing are nice, but let's face it, the high-speed loaders are the way to go. Low data info for MySQL is nice. Column databases typically have even a magnitude above that. So if you get 100 times benefit of low data infile over even the MySQL array inserts, you're going to get 100 times speed increase using the high-speed loaders that we provide and other people provide. So they're actually quite nice. Again, the row-based tables are going to load faster. If you're having to use ETL tools to shoot that data through, and it is inserts and such, your row-based tables are going to give you better performance than a column-based table is. That's just kind of par for the course. That's just okay. Loading data again in primary key format sometimes helps out these engines, InnoDB being one of them. Now, one thing, and I don't know if I've got it on this slide or not, no. One thing I do want to mention here, and I talked earlier about the CSV engine. One cool thing you can do, let's say you've got a MyISOM table or InnoDB or whatever, and you want to load that data into a column database or just another storage engine with a high-speed loader. How do I do that? Well, one thing you can do if you're in 5.1 and above is do an alter table, table name, engine equals CSV. Because it'll create for you a comma-separated value file on the disk for you. It's created your flat file for you. Then you just take your high-speed loader, you point it to that CSV file, and boom, load the data. Right? It's a nice, easy way of doing it rather than trying to do a select into, insert, or create an out file from it or something like that. Just do an alter table, create a CSV, and push it in with the high-speed loader. Works pretty well. That first point up there is also pretty critical. Get the data as close to your database and or your engine as possible. So one thing I did with Teradata early on, made a mistake where we created these applications that tried to take the legacy data and push it up into Teradata. And I remember the first night we kicked that thing off, and yeah, we come in the morning, it's going to be ready. And we came in the morning, it was like 1/10 of the way done, as it was pushing data up through Teradata's network and everything else. It was horrible. And so we had a Teradata consultant come in and said, no, you haven't done this. So he took it, and this is good advice for all of us, created staging tables from the raw data. So you take the raw data, now you have to have the space to do it, take the raw data, create staging tables that are just replicas of your flat files, and then you do your manipulation functions. If you have to do your transformations, do it on the database server itself rather than somewhere else. And be forewarned that if you're using ETL tools and such, some of them, not all of them, but some of them, let's say you're doing, you're firing off all this stuff and your ETL tool is running on your laptop, it's going to act as a router. And you don't want that. So it's going to go back and forth doing these type of things. You don't want that. So try to create the staging tables and use utility functions on the database server to then push that data into the database if you can. Let's see, second point already done. Loading data in time-based format also helps out. So for example, if you have time-based data where you're accessing it in a time-based format, what our extent map does, quit doing that. What our extent map does is it acts as then a horizontal partitioning scheme for you. So not only do you not have to index, but also you don't have to partition now. Because we create range partitions for you within the extent map, and it knows then when it begins to access those patterns, it works exactly like partitioning does. So you can, just by looking at that little extent map, it doesn't have to examine any partitions, it knows exactly where to go, eliminates the extents even more, and you get another I/O boost, which is really pretty cool, and really helps out with speed. Okay, now let's wrap up because I gotta go quick. Monitoring the design and tuning. Doesn't matter what's transactional, data warehouse. These are the methodologies that are used, always. Bottleneck analysis, workload analysis, ratio analysis. Some people prefer some over the others, but this is typically the order that works best for you, that will work best for you. Bottleneck analysis basically asks the question, what am I waiting on? Right? And if you watch what Oracle has done and some of the others, you saw them change their analytic techniques in terms of what they focus on diagnostic-wise. It happened probably around, I don't know, it started earlier, but really around 10G is when I saw it really change in 11 to really a workload analysis, bottleneck analysis type approach, which again uses wait events to say, what am I waiting on? Is it I/O? Is it table scans? What am I waiting on? That's the question it tries to answer. And unfortunately, with MySQL today, this is tough to do. Now, they put together a performance schema. It's a nice first step. In my opinion, I think it falls short of what you need today. When I was at MySQL, I designed a different performance schema that they didn't go with. Drizzle's actually implementing it, what I had designed, and it focuses on this weight-based type of stuff and that type of thing. And they'll get there, I'm sure. It's just not there today. So anyway, again, what happens though, when you can figure out what am I waiting on, typically what you'll do for your design is maybe there's some lock handling in your application you got to deal with, partitioning improvements, better indexing, or storage engine replacement. That's what you'll find. When you find you're waiting on something, those are the type of design areas that you'll be looking at to try to change. So bottleneck analysis, again, first one that you really need to be looking at. Second one is workload analysis. So is it just the heavy lifting just too much here for me? And here what you're focusing on in terms of answering the questions is, look, who's logged on, what are they doing, and can my machine handle it? Those are the questions workload analysis is trying to keep track of. So you're monitoring your sessions, who's logged on, what are they doing, and don't think just because they're idle, it's not sucking the life out of your system, because it takes some resources just for idle connections. So oftentimes it's good to go in and have systems or whatever that just do it, they kill them off. And some databases take care of that for you, all right? This is very nice here. The I/O and hot objects is a key area you want to focus on. So what areas on my server are hot in terms of disks and the areas there, and what objects are being accessed. Okay, that's why hot objects is important. And some of the, I think it's Percona patches that they've got out will help you with this. So identifying again what objects are getting hit, indexes are getting hit, so look those type of things up. But by far, the real area of focus is on SQL statements. And these are the things, after design, after you've put together a good design, this is the next animal to really look at. Because this is what will drain the life out of your system like a vampire, almost like no other. One of my Teradata systems, guy came to me and he said, I think this SQL statement's bad. And so I went over and I looked at it real quick, and I was kind of in a hurry, which doesn't happen to anybody I know, but I just didn't want to really deal with it at the time. And I said, well, have you run an explain on it? And he said, what's an explain? So, okay, he's new, obviously. And so put it through an explain. And it ran, and it ran, and it ran, and it ran. And it's never a good sign when the explain runs a long time. Now Teradata is kind of neat, because what Teradata will do is it will try to tell you, it will give you an estimate how long it believes it's going to take to run. So it will come back and it will give you a time and a date and a timestamp. This is when we believe it'll finish. So this was in the mid-90s. And according to Teradata, his query was going to finish in the year 2049. So it would have, quite a while. We're in 2010 here, so 39 more years. Those aren't the kind of queries you want running on your system, and you need to find them before they make it into it. And that's where the SQL statement analysis becomes very, very important. Again, in Rustin's report, why are people kicking out their systems? Poor query response. And sometimes this means you need a new system. A legacy database just isn't handling. But oftentimes it also says the database administrators and or the performance analysts just aren't doing a good job finding these things. Okay? And so really with, so with MySQL, you do have some help here. You do have a better, of course you've got explain, that's fine as a start, but there are some profiling tools that come in 5.1 and above that actually do a pretty good job of telling you step by step where your query is executing, how long it's taking, all of that type of thing. We also offer very nice tracing tools that are on par with some of the SQL servers and such that really give you a nice detailed analysis in terms of I/O and blocks touched and things that you really need from a diagnostic standpoint to figure out what MySQL statement's doing and how it's actually doing those type of things. Historical analysis also is important, and I know this is a bear, but it's nice to be able to capture these things and their query times, because maybe a query took 10 seconds today, a week from now it takes 20 seconds, 30 seconds, why is that happening? And you'll never see it. You'll just look at the last one and say, that's running 30 seconds. But you never knew that it used to run in 10 seconds. Well, what's changed? Data volumes, access patterns, concurrency, what's changed? So that's why historical analysis is really important. And your design changes here involve data striping, indexing, parallel processing additions, just to help, again, those linear additions that come from adding nodes and MPP environments, divide and conquer, all of that. Ratios, I'm not going to spend a lot of time on. They're nice rule of thumb, cache hit ratios, all that type of thing. It's not, stuff that's not somewhat helpful, just again, in terms of rule of thumb, but it doesn't help all the time. For example, logical I/O, just because all of your I/Os in memory doesn't mean your system's not going to crawl. I had a number of systems that looked at all these ratios and it's just, everyone's dying, and it's all logical I/O, but it's too much of it. So keep that in mind. So at the end of the conclusions, number one contributor, design. That's why you need to think about what you're doing. That's why I've entitled this talk the way I did. Think about what you're doing. Think about the things you're doing up front, laying that foundation. Just like a house, the foundation of the house stinks. Doesn't matter how elaborate and pretty it is above that foundation. It's going to fall, for sure. So the nice thing with MySQL, we have a lot of flexibility here. Lots of flexibility. Both with storage engines and ways of doing things and just mechanisms. Lots of flexibility for you to work with and try out and see what works best for you. And again, you're looking for a future-proof solution so you can run fast and handle as much data as you like. Final one plug that I will make, if you want to try out a column database, love for you to try us out. Don't ignore our competitors. See which one works best for you. 20 megabyte download, 2 instructions to install, looks just like MySQL, kick the tires, see what you think. Try the others, try that as well. Okay, I can see that we need to exit here. So if you do have any questions, I apologize, we ran a little late. Please see me now. I'm happy to talk to anybody and answer anything you have. Thanks for your time.